Most elements in our universe are formed through a process called stellar nucleosynthesis, where stars fuse lighter elements into heavier ones. However, this process can typically only create elements up to iron, atomic number 26. Gold, with an atomic number of 79, requires a much more violent cosmic event. That gold jewelry you're wearing? It was literally born in the stars. Like and subscribe to learn more fascinating facts about our world. The primary method of gold formation in our universe occurs when neutron stars, the incredibly dense remnants of massive stars, collide with each other. These rare cosmic events create the perfect conditions for rapid neutron capture, known as the R process, or rapid process. During a neutron star collision, temperatures reach over 100 billion degrees Celsius. Gravitational waves ripple through space-time. A tremendous explosion occurs called a kilonova, and neutrons bombard atomic nuclei at incredible speeds. These neutrons are captured to form heavy elements like gold. Scientists confirmed this theory in 2017 when they detected gravitational waves from a neutron star collision and simultaneously observed the spectroscopic signature of newly formed heavy elements, including gold. Some gold may also form during certain types of supernovae, the explosive deaths of massive stars. However, research suggests that neutron star mergers are responsible for creating the majority of gold in our universe. After formation in these cosmic events, gold atoms disperse through space, eventually becoming incorporated into molecular clouds that collapse to form new star systems. Our solar system formed from such a cloud about 4.6 billion years ago, carrying with it the gold created in previous stellar generations. When Earth formed, most heavy elements like gold sank toward the planet's core during its molten phase. This explains why gold is relatively rare in Earth's crust compared to its overall abundance in the planet. Much of the accessible gold near Earth's surface likely arrived later during the late heavy bombardment, about 4.1 to 3.8 billion years ago, when asteroids, some containing gold from different cosmic sources, collided with our young planet. Gold doesn't typically form concentrated deposits immediately. Instead, several geological processes work to concentrate gold into economically viable deposits. The most important process for creating miniable gold deposits is hydrothermal activity. Groundwater gets heated by magma deep within the Earth. This superheated water dissolves minerals, including gold, from surrounding rocks. The mineral-rich water travels through fractures in the rock. As the water cools or encounters certain chemical conditions, gold precipitates out. Over time, this forms veins or lodes of gold within rock formations. These deposits typically form at convergent tectonic plate boundaries where there is significant volcanic and seismic activity. Weathering and erosion break down gold-bearing rocks over millions of years. Gold is resistant to chemical weathering. As rocks erode, gold is freed from its matrix. Due to gold's high density, which is 19.3 grams per cubic centimeter, it settles in stream beds. Rivers naturally sort materials by density. Gold accumulates in placer deposits in rivers and streams. Carlin-type deposits are characterized by microscopic gold particles disseminated through sedimentary rock. Epithermal deposits form near volcanic centers at relatively shallow depths. Porphyry deposits are low-grade but large-volume deposits associated with porphyritic intrusions. Gold's exceptional qualities derive directly from its atomic structure and cosmic origins. At 19.3 grams per cubic centimeter, gold is one of the densest naturally occurring elements. A single gram can be beaten into a sheet covering nearly 1 square meter. It can be drawn into extremely fine wire without breaking. Gold is also an excellent conductor of electricity and heat. It's highly reflective, especially of infrared radiation. And of course, it's extremely resistant to oxidation and corrosion. Gold is among the least reactive elements, which explains its persistence in nature. This chemical nobility means it doesn't tarnish or corrode in air or water. It resists most acids, though it dissolves in aqua regia. It doesn't react with most other elements under normal conditions. It maintains its luster indefinitely. These properties are directly related to gold's electron configuration, particularly its filled d subshell, which creates exceptional stability. Gold has functioned as a store of value for over 5,000 years of human civilization. This makes it one of the longest-standing financial assets in human history, predating all modern currencies. Throughout history, gold has maintained purchasing power during the fall of empires, economic depressions, world wars, currency collapses, and hyperinflation events. Gold typically has a low or negative correlation with other asset classes. When stocks decline during economic uncertainty, gold often rises. During the 2008 financial crisis, the S&P 500 fell 38%, while gold rose 5.5%. During the COVID-19 market crash of March 2020, gold initially fell but quickly recovered and appreciated, while many stocks remained depressed. This negative correlation makes gold valuable for portfolio diversification, potentially reducing overall volatility. Gold has historically preserved purchasing power during inflationary periods. During the 1970s inflation crisis, gold prices rose from $35 per ounce to over $800 per ounce. Gold tends to maintain value when fiat currencies lose purchasing power. The limited supply of gold, all gold ever mined would fit in a cube roughly 21 meters on each side, contrasts with potentially unlimited currency printing. Gold prices often rise during wars and military conflicts, political instability, trade disputes, economic sanctions, and currency crises. This occurs because gold is seen as a universal store of value, not tied to any specific government or financial system. As central banks engage in quantitative easing and other monetary policies that increase money supply, the relative scarcity of gold becomes more pronounced. Countries like China and India have cultural affinities for gold and growing middle classes with increasing purchasing power, supporting long-term demand. Coins. Government-minted coins like American eagles, Canadian maple leafs. Bars range from 1 gram to 400 ounces, known as good delivery bars. Jewelry, though typically carries a premium over the gold value. Pros: direct ownership, no counterparty risk. Cons: storage costs. Insurance needs, potential liquidity challenges. Examples: SPDR Gold Shares, ticker symbol GLD, and iShares Gold Trust, ticker symbol IAU. Pros: high liquidity, no storage concerns, fractional ownership. Cons: management fees, counterparty risk. There are different types of gold mining stocks: senior producers, mid-tier producers, junior miners, and exploration companies. The pros include potential leverage to the gold price and dividends from profitable miners. However, the cons involve company-specific risks, operational challenges, and jurisdiction risks. Gold futures offer leverage and capital efficiency, but they also come with complexity, expiration dates, and the potential for significant losses. While gold preserves value long-term, it can experience significant short-term volatility. For instance, from 2011 to 2015, gold declined from $1,900 per ounce to around $1,050 per ounce. Daily price movements can be substantial during market stress. Gold pays no dividend or interest, creating an opportunity cost when interest rates are high. Physical gold requires secure storage solutions, adding to the total cost of ownership. Entering the gold market during price peaks can lead to extended periods of negative returns. Most financial advisors suggest a gold allocation of 5 to 10% of your investment portfolio, viewing gold as insurance rather than a growth asset, a long-term holding perspective of over 5 years, and dollar cost averaging for entry rather than making a lump sum purchase. From its creation in cosmic cataclysms billions of years ago to its role in modern investment portfolios, gold represents something truly extraordinary, an element that connects the physics of the universe with human economic systems. The same properties that result from gold's nuclear formation, its scarcity, stability, and uniformity, are precisely what make it valuable as an investment. In this way, the financial role of gold is not merely a human convention, but is deeply connected to fundamental physical properties derived from its cosmic origins. As one of the few elements that maintains its fundamental characteristics across cosmic, geological, and economic timescales, gold remains unique in spanning the domains of astrophysics, geology, and finance, truly an asset forged in the stars.